Welcome, everyone. Okay, let's dive right into this explainer. We're looking at July 14th, which is honestly one of the absolutely greatest dates in all of math history. And here is exactly why. On this one single date on the calendar, stretching across completely different centuries and different countries, brilliant minds ended up changing the entire world we live in today. So here's our chronological roadmap for July 14th, 1793, 1827, 1865, and 2017. But before we start dropping names, let's start with a bit of a mystery. Have you ever actually wondered why your phone screen can show millions of crisp colors, or how the optical lenses in our cameras capture light so perfectly? We rely on this tech literally every single day, from taking a quick selfie to streaming movies. But how does that light actually behave? Well, the answer takes us to July 14, 1827, and a guy named Augustin Fresnel. Born in France, Fresnel was a civil engineer, but he spent his free time absolutely fascinated by the science of light, running these incredibly intense experiments while he was on vacation. And here is his massive, game-changing achievement. Fresnel proved that light doesn't just shoot straight like tiny bullets or particles, it travels in waves. He discovered the underlying math behind diffraction and polarization. Using what we now call Fresnel's integrals, he could mathematically calculate the exact position of bright and dark lines of light. Because of this exact math, the optical lenses in our modern cameras and the light shining from our screens work perfectly. He even used this knowledge to develop compound lenses for lighthouses, which ended up saving countless lives at sea. And this quote brilliantly captures his big aha moment. See, when he submitted his mathematical model, the famous mathematician Poisson tried to prove him wrong. Poisson deduced that if Fresnel was right, there would be a bright spot of light right in the dead center of a solid object's shadow. Well, they tested it, and boom, the bright spot was there. There is no darkness anywhere along the central perpendicular behind an opaque disk. Light really is a wave. Stepping back into our roadmap, we're still on July 14th, but let's jump back to 1793. Now ask yourself, why does your Wi-Fi signal actually work? And how does electricity just, seemingly magically, travel into our homes to power absolutely everything we own? Think about those invisible forces of electricity and magnetism. Who on earth figured out the rules for that? For that answer, we go to July 14th, 1793, the exact day George Green was born. Green was an incredibly gifted, self-taught mathematician from England. He actually spent years working in his family's windmill, and yet he still managed to crack the code of these invisible forces. So, Green coined this term, the potential function. Essentially, it's a mathematical result you get by taking the masses of all the particles in a system and dividing each one by its distance from a given point. He introduced what we now call Green's theorem, which connects surface and volume integrals. Basically, by mapping out this very specific math, he gave us the power to understand, calculate, and ultimately control electricity and magnetism. The crucial takeaway here is that George Green gave us the invisible math that powers every electrical device we use today. Without the foundation he laid on potential functions, the electrical grid, your phone battery, your Wi-Fi, none of it would exist in the way we know it. Okay, leaving the 18th century behind, let's leap forward to 1865. Have you ever wondered how health apps, insurance companies, or even governments predict human lifespans? Like, how do they statistically understand the human aging process so they can actually plan for the future? This answer goes back to July 14th, 1865, and a man named Benjamin Gompertz. He was a brilliant, self-educated mathematician and actuary from London. Interestingly, because of his background, he was actually denied admission to universities. But he absolutely did not let that stop him from educating himself and becoming a total pioneer in actuarial science. Gompertz applied differential calculus to calculate life expectancy. He showed that mortality rates increase in a geometric progression. What that really means is that he successfully mapped the human aging process as a straight line on a logarithmic scale. His law of mortality is the literal mathematical foundation we still use to this day to measure how populations age. Just think about this fascinating realization for a second. The rate of our aging is a mathematical slope. The differences in longevity between species are primarily just the result of differences in the rate of aging, which is expressed as differences in the slope of the Gompertz function. Our very lifespans can be graphed mathematically. Mind-blowing, right? For our final stop, we're jumping all the way to the 21st century. Destination? July 14th, 2017. Let's set up our final mystery. How do we calculate the paths of objects moving across incredibly complex, chaotic, curving surfaces? Imagine trying to track movement across the twisting dimensions of the universe itself. The answer brings us to July 14th, 2017, and the extraordinarily gifted Maryam Mirzakhani. She tragically passed away on this exact date. But man, she left behind a legacy of mathematical optimism that literally changed how we see the world. She brought incredible order to complex geometry. She explored curving, chaotic surfaces and mastered the ridiculously difficult math of calculating exact paths across them. She tackled problems in spaces that initially seemed completely hopeless to other mathematicians. Her work is absolutely crucial for modern physics, quantum field theory, and understanding the very fabric of our universe. I really want you to remember this powerful quote from her. If we knew things would be so complicated, I think we would have given up. I don't give up easily. Her colleagues always said her optimism was infectious. She is just a stunning example of the value of persistence in the face of intensely complex problems. So let's bring all four of these historical dots together. Green in 1793, Fresnel in 1827, Gompertz in 1865, Mirzakhani in 2017. Look at the massive impact of this single calendar date. These diverse breakthroughs spanning centuries are the secret ingredients to our modern reality. We've got the wave theory of light shining from our screens, the potential functions powering the electricity in our homes, the law of mortality predicting our lifespans, and the mathematics mapping the complex geometry of our universe. Every single person we met in this explainer today, across totally different centuries and countries, essentially asked the exact same question. What is the pattern hiding inside the chaos? And because they were brave enough to ask and persistent enough to do the math, they changed our world forever. So, as we wrap things up, I want to leave you with this provocative thought. What pattern will you